and this is Physics Lab 1, Oscillations. Here's a quick rundown of what we'll be going through today. Let's start with an introduction. What is the purpose of this lab? The purpose of this lab is to predict the motion of our system to demonstrate fundamental principles, including Newton's second law and the energy principle. The system includes Earth, spring, and mass, and the surroundings have no forces. The energy of our system is 0. On the right, you can see a free body diagram where the force of the spring points upward and the force of the gravity points downward, and the mass is in the center. Here are some formulas that we'll be using. As you can see, we have kinetic energy, gravitational potential energy, spring potential energy, total energy, which is the sum of those three previous forces, force due to gravity, position and velocity update, which will be used in the Glowscript, period of oscillation, spring constant, and other spring properties in order to set up the Glowscript model. So here's the experiment. As you can see, the mass begins hanging at 0.7 meters below the origin, and as you can see, it begins to oscillate once it is let go. On the right, we can track the X and Y position as it oscillates, and it generates a set of values which will be used later. So, in order to generate the computational model, we will be using a set of inputs. As you can see, the ball's initial position is set, the ball's mass is edited. As you can see down here, the kinetic, potential, gravity, potential spring, and total energy formulas are inputted. Also here, this is the time of the oscillation, and there's also force net, force grav, force spring, which will be used to generate the graphs. So once you run the model, we get a simulation that looks very similar to what we saw in our video. On the left, we also have our change in energy versus time graph. In blue, there's change in kinetic. In red, change in potential gravity. Change in green, change in spring energy, and orange demonstrates the total change in energy of our system. And on our right, our model is in blue, and our experiment is in red. And as you can see, the positions are very similar due to the accuracy of this model. Lastly, the discussion questions. So what does this actually mean? Is the energy principle satisfied? Yes. The sum of the change in kinetic, potential gravity, and potential spring energy is equal to the total change in energy, or 0. Therefore, energy is conserved and no energy is lost. Lastly, estimate the oscillation period. So in order to find the oscillation period, we can divide the number of oscillations by the time it takes them, and we can also estimate this by looking at the distance between crests. And so through doing all this, we can estimate that the change in the x distance oscillations is 1.6 seconds, and the change in y oscillations is 0.8 seconds. Thank you.